All right, we're going to continue on. This is 3.2, so this is covering compound interest and continuous compound interest. All right, so this is now we're working into loans and investments that are more than a year. Simple interest was used when it was less than a year. Now we're getting into where it's a longer system. So one thing that you want to always be aware of is how often are you investing, okay? Or how often are you making payments? So in this case, when we're doing compound interest and continuous compound interest, it's one investment. One time I put money in and I leave it alone, okay? Or one time I make a payment and that's it, all right? Or I pay it off in one payment. So this is just a single payment. That's it, just one payment. And so we're going to work on, let's do compound interest first. Now, in MyMathLab and in the textbook, they use different variables than what I use. So I don't want to confuse you on the types of variables. So I'm going to give you what the book and MyMathLab gives you, and then I'm going to relate it to how I write it. So in the textbook, so in MyMathLab and the textbook, they use different variables. So they use the letter I for the variable R over N. Okay, the rate over the number of compounds. I don't like the I. I is imaginary number. So that's why I fight it all the time. So they also use N in the textbook, and they use it as M times T. I do N times T. Okay, I know it's confusing. Once you know what they all mean, you'll be fine. And then M in the textbook they use as the number of compounds, and I use the letter N. Okay, so here's what the textbook. So this is the formula for compound interest. Okay, now how you know what to use, because obviously we're building, I'm introducing more and more formulas. If you see that the investment or the problem is less than a year, you're going to use simple interest. Okay? If you see that it says monthly and there is one single payment, you're going to use compound interest. If they use the term continuous, you're going to use the continuous compound interest formula, okay, which I'll introduce in a minute. All right, so compound interest is written this way. A equals P times 1 plus R over N raised to the NT. This is how I write it, okay? This is how your textbook writes it. Okay, so the I is my R over N. The N is my NT. And notice I don't use M. I think it's too confusing. Okay? All right, so just so you know that these all mean the same thing. All right, so what do all these values mean? A is just like simple. It's your ending amount. It's the total at the end of whatever number of years that you're working in. P is your principal, or the beginning amount. R is your interest rate, and it must be as a decimal. Okay, so nothing's different, right? Nothing's different. T is your time in years. Okay, so now when it says 7 years, you don't have to do 7 over anything. It's just the number of years. So here's the difference. N is the number of compounds. In other words, how often do you earn interest? If it's compounded monthly, you think how many months in a year? There's 12. So your N will be 12. If it's quarterly, that means you get paid 4 times a year. There's 4 quarters in a year. If it's daily, you get paid 365 days a year. If it's weekly, you get paid for 52 weeks. Okay, so the end can change depending on how often the interest compounds. All right, so you have all your information. Now let's try it. Now I'm going to leave that up there so you can see the connection. All right, so let's say we have a one-time payment of $1,000. We have an interest rate of 5%, which is 0.05. We're going to leave it in for 10 years, and it is compounded monthly. Okay, so I want to know the ending amount. Okay, I want to know what am I going to end with if I leave it alone for 10 years. Put money in one time, just let the interest grow. All right, so here we go. A is what we're looking for. P is $1,000. 1 plus my R is 0.05 over my N, which is 12, because it's monthly, so we have 12, all raised to the 12 times the 10. Okay, so the difference between how I set it up so I have every piece. In the book, they may say you have 120 payments. So you can have this all as one number if they tell you how many payments it is, or how many times a year, not payments, I'm sorry, how many times a year you're going to earn interest. Okay? So in this case, this right here represents the I. So R over N represents the I. And this represents the number of compounds times the number of years. All right? So now we have to do order of operations. All right? It's very important. You're going to do this number first. So I get 1,000 times 1 plus 0.05 divided by 12, all raised to the 120. 12 times 10. Now I'm going to do parentheses. So 0.05 divided by 12 plus 1. So inside the parentheses, I have 1.004166667. That is all raised to the 120th. So parentheses. Now I'm going to do my exponent. And if you notice, I'm not clearing this. I just put this in plus 1 raised, so you can use your hat key, to the 120. And I'm writing this down so as you're doing it, you can check your calculations and make sure your calculator is doing the same thing. So that raised to the 120th is 1.647. And then I'm just going to multiply it by 1,000. And my amount, oh boy, my amount is 1,647.01. So you're always going to round to the second place value. Okay, so here's what this means. I put $1,000 in, I earned 5% interest, I left it for 10 years, my interest was built 12 times a year, and the end is $1,647.01. So my interest, the amount that I earned, was $647.01. Okay, so that is one example. All of these you're going to have to you're going to be able to find the unknown on every single one of these. We'll pick an unknown and then you'll be able to solve for it. So I'm going to stop there and then we'll do some more examples.